Hello guys, so we received some feedback from you about the genetic algorithm and that some of you don't understand the genetic algorithm yet. So we decided to re-explain some parts of it again. So today I will try to re-explain what we did in the lab for week 8, week 9, sorry. So about like the traveling salesman problem. So let's start. My key points would be today firstly to explain why we need the GA algorithm, and two would be that I will explain the genetic algorithm in details, its steps in details, and three would be just to explain how to apply the genetic algorithm to our traveling salesman problem. So let's start why we use genetic algorithm. So normally, like for example, we have a 20 city, a number of 20 city. So this 20 city, like if we would have like the traveling salesman problem, how he would go like between them, what is the possibilities, like what is your solutions or possibilities to go between these 20 cities. So this problem, it would be a problem of n minus 1 factorial over 2, which is 19. If we have 20, so it will be 19 factorial over 2. So like to imagine more like how big is this number, so let's go and calculate it. So this number would be simply 19 factorial divided by 2. So like 10 power 12, it would be trillion. 10 power 15, this is something called quadrillion. So this is about 60 quadrillion. It's very big number. So let's imagine that we can do maybe 1 million process, like for example, like we can process 1000 solution or 1 million solution per second. So like each solution can take, for example, on our computer it would take like 1 microsecond, only 1 microsecond. So this would give us, so if each solution would take 1 microsecond, this means that we can process 1 million solution per second. So this is the number of seconds that we will need to like to brute force all the solutions that we can do for this problem. So let's divide this is the number of seconds, so let's divide this by 60. This is the number of minutes, another 60. This is the number of hours, divided 24. This is the number of days, divided 365. This is the number of years you would just take to loop for all possibilities for this problem. So unless you want to wait, this will not be effective to brute force all the solutions for a problem like this. That's where it's come, like the genetic algorithm. The genetic algorithm can give you like good solution, very near to optimal. It doesn't guarantee like it will give you optimal, but it can like give you like something close to optimal, and it can even give you like the optimal solution in like a no matter of time, like maybe just few seconds or maybe minutes. So like that's indeed like a very good trade-off, like to use like the genetic algorithm. So let's continue. So this is why we use like the genetic algorithm. So let's just cancel it. So let's explain like the genetic algorithm in more details. So as we said, like you have like this number of solutions, or that would take if you just will go for all possibilities to go between those cities. which is not efficient. So what is the alternative? How like we can apply the genetic algorithm for such a problem? So here, like for our traveling salesman problem, we will have, let's just clear everything first. So for our traveling salesman problem, it would look like this. We have like some cities distributed on the XY axis, and each city have coordinates, and we can just calculate the distance between any of the two cities. So the problem would be that we want the least distance. We want to search for the least distance between all of these cities. So in this case, what to do, like, or how, like the genetic algorithm. Let's talk about the genetic algorithm first, how it works. So the genetic algorithm is working in the following order. So firstly, we need to get our population. So what is the population? The population would be like, for example, your input. We can describe it as our input. For here, like our input would be just maybe like some sort of solution. So like maybe if I will go from like these solutions, if I will start from example 1 and this will be my route, then this is my solution. For example, it's maybe an array for the visited cities. So like it would be 1, 12, 11, so on, like until you get back to 1. And you would calculate just so like the population, it will be like this solution and another other solution and other solution, etc. So imagine that you have like 100 solution in your population here. So this would be like just your population. Next, what you need to do for with this population, you need to calculate your fitness. So what is fitness? For example, we need to like evaluate this scores, the scores for these solutions. For example, like we need something that tells us this solution is good and this or this solution is bad. So the higher the fitness, the higher the fitness, the better the solution. Better the solution. So we need to ensure that our solutions have a high fitness. And what is better solution for us? The better solution for us is that the length of the routes, the minimum length of this route. So for example, if this route give me 1572 total length, 0.68 for example, and another route give me 1700, and other route give me 1402, and so on, and maybe one give me 2100, and so on. So I would evaluate all the distance for all of these solutions. That's the second step, like giving the fitness for all of this solution. And then we would just pick up like the fittest between them. So like the solutions that have a higher fitness score, this will be like our choosing population for the next generation. So for example, like how we can like ensure that the best solution. So for example here, the routes that have like the minimum solution, it would be for example choosing, this would be our choosing criteria here, for example. So for example 1400 and 1572, that would be like our best option for now. But as you can see, like we said that before, we need to choose the least bus, but this number is not corresponding to a higher fitness. So what to do in this case? Like we need this number or the fitness to be higher in order to be chosen. Like this is the default for the genetic algorithm. So simply we would just maybe give it a negative number or just divide it by 1. So for for example, we want the main length for each solution, which would just translate it to, if we wanna give it like for a fitness function, it would be just, and we just like we want the minimum length to have a higher fitness, so we can just make it like this over the length of each route, or we can just negative the length. So in this case, if we have like here, for example, if I would make 1 over 1402, in this case I am ensuring that this solution would have a higher number than every of the other solution. If I will do this for all, then this solution would have a higher fitness between all the others. And even if I give it a negative number, I am ensuring that this would also have a higher fitness score. So for example, this would be, the other one would be 1572 and negative 1700 and negative 210. So this would be like the highest fitness. So now we did like we now like here defined our population and calculated our fitness, like we like just fit our problem to the best fitness, or like here we want the minimum distance, then we translate it to a higher fitness score. Then what we need to do else, let's just clear and so first we did calculate the population. Second, we calculated our fitness. So now, after we calculated our fitness and we just have like the fitness for each of the solution, we have its fitness. So we need to sort it. So like we will choose, maybe we have 100 population, 100 like solution in our population. We will just choose the first 10, the first fittest 10 solutions. So for example, like the first 10 that have the highest fitness score, we would choose them to go for the next generation. So this is a way, by the way, for the fitness, like to choose, for choosing your the solutions that will go for the next generation. There is like a lot of ways. There is a lot of ways, like we can just choose like the one with the highest fitness, or we can choose like the rolled wheel, as we did in the tutorial. Rolled wheel, just like the fittest like will have a higher probability to be chosen, but it will be still random, like will still randomized. So we have like many ways. You can choose whatever you want here. So like here is just like we can say it's hyperparameter for the algorithm. But here, like for example, for this example, we would just choose the highest fitness, and even if you choose any other way, you would like reach, probably at the end you all can reach you like a good solution. But just like it's a hyperparameter, you can choose whatever you want. So here we will choose the fittest solution, like the highest fitness score solutions. So after we choose like our solutions for the next generation, then for example these solutions will be like the parents. So what is done, so like imagine that we have like 10 solutions, as we said, we choose 10 solutions. So this 10 solution would take just every two of them, like for example here it would be first, and here it would be second solution. So like for first solution we can call it father, and for second solution we can call it mother. So this solution is just like an array of the 20 like how we can go between sets. So for example, like 1, 12, 17, and so on, like until we route like have a route for all the 20 city. And the mother would be like the same, maybe like to 15 and so on, until like we have like a 20 cell like for the route between city. So what to do, like imagine, let's do it in a more clear way. So uh, let's imagine that we have just uh, maybe 3 or 4 city. So if we have 4 cities, for example, like just imagine for the sake of explanation here, imagine we have like 4 sets, only 4 sets, 1, 2, 3, and 4. So for father, for example, like we found that 4, 3, 1, 2 is a good solution, was one of the highest, and the mother was, for example, 2, 1, 3, 4. So what we can do here is just we need like for them to do crossover. This step 3 is the crossover step. So what is the crossover? The crossover is that we just take the head, for example, from the father and the tail from the mother. So it would be, for example, the child would be something like this. So for example, we would take just from here the head, which is 4 and 3, the head, and then we take the tail from the mother. But here, for example, like we would just put it here, but for our problem it can't be, because we can't go for a city twice. So here we have 3 and 4. So if we have like the 3 and 4, then we would just simply change it with another value. So like here we found that 3 and 3 was already in the child, so we just replace it. So we can choose like any of the unvisited or cities, which is 2, and then we search what is like still needed, so it will be 1. So this is like, for example, we just from this crossover we did like another child, and that's what is done in the algorithm in some part here, that we just like, if you found that it was repeated, we can just simply uh, like loop for the fuzzer again and randomize anything, and then we go again. If it was another one chosen, then we go and randomize the value. But for example, if we have another solution, for example, that was something like this. So for example, 4, 2, 3, 1. So for example, if this was our father and this was our mother, and we would take like the tail from here and the head from here, then it would be something like, the child would look like this. It would be 4, 2 would take like this from the father and this from the mother, 1 and 3. It would be like simply like this. But if we found that some of them are repeated, then you just go to father again and take its value and one of its value and put it, and then so on and so forth. So that what we do for the crossover. So now we have like this child, we need to go to the 4th step, which is mutate. So what is mutate? Mutate is just to choose any element, or this is like, this solution is called chromosome. So any of these solutions is just called chromosome. So, and each element in this solution is just called gene. So for the mutate, we just choose any random element and do a mutation. What is mutation? We just change its value. Like we go like for this element, for example, and this element, and we just do mutation, like replace them together. So it would be 4. We replace this with this 3, 1, 2. So that would be our offspring, or our new child. This would be like one of our new generation solutions, and we just go there, go here for like we go like for the population, our first population, not here, even like here, the population that was contained 100 solution, and we just replace maybe like, if we would get here a 10 offspring, then here we go and replace the last 10, the last fits 10 from here, we just replace them, or maybe we will just replace all the list with the new offsprings. So why we are doing like this? So for example here, we just try to make our algorithm converge to the best solution as far as we can. So how we can make it converge? We are just trying to generate the fittest solutions, and then to do a crossover between them. So we take the best between these solutions, and we try to make a better solution. But for this crossover, what happened is just take the best from the father and the best from the mother, but it also take the worst from the father and worst from the mother. So to avoid like overfitting or just repeating the answers, we just doing this mutate. We give it like some random value that it might get better. It might for sure get worse, but at least we are ensuring at least that we can sometime get better. And if we get better, then if we got better, then it will like after a crossover again, or after this better solution generated, it will be in our list, and that's maybe it will like generate a better child next time, and so on and so forth. So that's the idea for now behind the algorithm. So let's go here and explain some of the code. So like this is just the coordinates for the city, the each city. Like for example, we have 20 city, and that's just the coordinates for it. And what else we need? Here is like we are defining our fitness function. So for our fitness function here, as we say before, that each chromosome or each individual, it will just have just a distance. Like for each solution, we can just get the distance between these cities, and this fitness can be just the negative value from this distance. So like the least the distance, and we give it negative, then the higher the fitness it will be. And what else do we need to explain here? Here is just some functions that will help you like to compute the distance between like the coordinates of the cities, and another functions that can calculate you like the distance or the route length for your solution, which will be used for sure like to get the fitness. And here's just some helping function to make the plotting. What else do we need to explain here? So here is like the part that I talked about here, which is just the father and mother, and we are trying to take the mother head or father head and mother tail or father tail, like any of them, just like do the crossover part, and to ensure that they are not repeated. And what else? Here like just the mutations, that we just choose some random value, and we just replace them together, like any like random elements from our child here, and we just replace them. And here's just like the function. And what else from the hyperparameter of our algorithm is the number of generations. You define the number of the generations that your algorithm will work for, and like the more generations for sure, the better um, offsprings you will have, or the better solutions you will have at the end. For example, if you like run just 10 generations, it will not be good enough. But if you run for example 500, it will be better. And for example, if you run uh, 1000 or 10,000, it would be better and better. As you can see here, like your like for some generations, it would get for like at the beginning, like till 100, it's just increasing. The fitness score is increasing, which means that the distance, this fitness score, as we agreed before, is just the length between the cities. So like, which means that the length is decreasing. You are finding better options or better solutions, and after some iterations, it started to like just not grow like so much. So the slope is now not growing so much, and maybe like after like 500 and maybe like to 1000, it will grow but not so much. So like, yeah, you can have more generations, but you will have more time in this case. So like, you need to find like a trade-off also, like between number of generations, so you save your time and get like the like maybe like a good value for you, or a good solution for you. And for sure, like, as you know, like this is so important because like for some companies like Amazon, for example, to deliver some packages to a neighborhood, the salesman is just like need to find the best route between like houses to travel among them. Or for example, like for a company that just it's just clear. Or for example, like for companies that make PCB uh, ships, for example, and it needs to drill some holes in its PCB chip, and like this driller, which need like for example to drill maybe 1 million chip, so like they need to find the least distance between the holes to be efficient as much as it can, because like like time in industry is money, and they need to be efficient, like do it fast and with least cost. So like that's why like to find an optimal solution for this kind of problems is very important. So what else do we need? mm, so like this is solution. By the way, we need to like just tell like last thing. Your final solution will depend also like on like the random values that you gave at first. So like maybe I gave random values different than of yours, and so like my final solution would maybe like a little bit different from your solution. So it's just normal. So like maybe every time you will run the algorithm with different values, it would give like a little bit different solutions, but at the end they will converge, and they will like have like a very close values. So like here, as you can see, through generations, it can find like a better solution, and the distance between the cities is getting smaller and smaller. Now it's 1572.68, and maybe like now we are like maybe overfitting, or we don't find a better solution easily, but maybe after some generations again it will start to find a better solution. So like here it was done for 1000 generation. So like they do like all of we explained for the genetic algorithm 1000 times. Like they repeat the steps, they repeat for number of generations to find like the best solution. And maybe like if we will go over 1000 generation, then maybe it will be better for you. So that's it for this tutorial or this lab explanation for the genetic algorithm. Hope you like enjoyed, and maybe like you have a little bit idea about it now. And if there's any problem, I can also maybe later I can do a video for the genetic algorithm for the bus planning. But for now, what you need to know is that you need the genetic algorithm is just an algorithm that you will need to like make it fit your problem. You need to choose your input and what is your objective from it, so what will be your output, and based on this you decide what is the best for you, how to choose your fitness function. It's up to you, like you can choose whatever fitness function you want, and how you gonna like select, what is your criteria for selection the best solution. You have like many ways to do it, and all of this like hyperparameters like number of generations and all of this stuff is just like you can decide whatever you need to do. So that's all for today. Thank you for your watching, and see you next time.